You are floating now, weightless, suspended in a darkness so profound it seems to have texture and weight of its own. Around you stretches an emptiness that has never known the warmth of a nearby star, a silence so complete it becomes almost a presence, a companion to your journey. The cold here is not merely the absence of heat, but something far deeper, a stillness that has existed since before human eyes learned to see. You are drifting, and drifting, and drifting still, carried forward by momentum alone, through a void so vast that distance itself begins to lose meaning. And so we begin our voyage not at a launch pad or mission control, but at the moment of farewell. September 5th, 1977 marked the date when humanity sent forth a messenger into the dark, though this messenger carried something far more precious than instruments and circuits. From the Kennedy Space Center in Florida, Voyager 1 rose on a column of fire and thunder, beginning a journey that would stretch far beyond the lifetime of most who witnessed that liftoff. The spacecraft itself was modest in appearance, roughly the size of a small bus, weighing just 722 kilograms, a fragile vessel to carry human hope and curiosity into the void. In those early years, as Voyager 1 climbed away from Earth's gravity well, it carried with it something unprecedented in human history, a golden phonograph record, carefully curated by a team led by astronomer Carl Sagan. This golden disc contained sounds and images from Earth, a time capsule meant for any civilization that might one day encounter the spacecraft. On its surface were encoded greetings in 55 languages, mathematical and physical formulas, and the music of Bach, Beethoven, and Mozart. There were also more humble sounds, the laughter of children, the crackling of a fire, the calls of whales singing in Earth's oceans. In this way, the spacecraft became not merely an instrument of science, but an emissary of human culture and consciousness itself. The mission planners of 1977 designed Voyager 1 to accomplish the first grand tour of the outer planets, a trajectory that would take advantage of a rare planetary alignment that occurs only once every 175 years. This alignment, occurring in the late 1970s and early 1980s, would allow a single spacecraft to visit Jupiter, Saturn, Uranus, and Neptune in sequence, using the gravitational assist of each planet to slingshot toward the next target. The engineers at NASA's Jet Propulsion Laboratory calculated that such an alignment would not occur again within a human lifetime, making this the singular moment when such an ambitious journey might be possible. So Voyager 1 became a vessel not just of discovery, but of a fleeting cosmic opportunity. The journey through the solar system unfolded with a sense of grand revelation, each planet emerging from the darkness like a character stepping onto a stage. In March of 1979, 16 months after launch, Voyager 1 approached Jupiter, the first of the gas giants in its path. This enormous world, with a mass greater than all other planets combined, revealed itself through the spacecraft's cameras in increasingly vivid detail. The Great Red Spot, that vast storm system larger than Earth itself, came into view with an almost hypnotic swirling pattern. Temperature readings indicated that Jupiter's upper atmosphere measured roughly -110 degrees Celsius, a cold so intense that it transforms our usual sense of temperature into something almost abstract. As Voyager 1 passed through the Jovian system, it discovered something that would reshape our understanding of planetary worlds. The 4 large Galilean moons, Io, Europa, Ganymede, and Callisto, revealed themselves as complex worlds worthy of study in their own right. Io, that innermost moon, showed active volcanoes erupting sulfur compounds into space, making it the most geologically active body in the solar system. Europa's surface, smooth and streaked with lines of dark material, suggested the presence of a vast ocean of liquid water beneath its icy crust. These discoveries, captured by Voyager 1's imaging systems and transmitted back across 550 million kilometers of space, fundamentally altered how humanity understood the possibility of diverse worlds beyond Earth. From Jupiter, Voyager 1 accelerated toward its next target, Saturn, now traveling at approximately 17 kilometers per second relative to the Sun, a velocity sustained across all the years to follow. In November of 1980, after a journey of 3 years and 2 months, Voyager 1 arrived at Saturn, that ancient god of time and distance, recognizable by humanity since before the invention of the telescope. Saturn's ring system, which had appeared as a simple flat disk through Earth-based telescopes, revealed itself to be far more intricate and beautiful than any artist's imagination could have conceived. Thousands of individual ringlets, each with its own distinct composition and orbital characteristics, formed patterns of almost geometric precision. The Saturnian moons presented their own revelations. Titan, Saturn's largest moon, possessed an atmosphere, the only moon in the solar system with a substantial atmosphere of its own. Its surface remained obscured beneath a thick haze of orange hydrocarbon clouds, but infrared instruments penetrated the veil to reveal mountains and valleys below. Enceladus, a smaller moon, displayed evidence of internal geological activity, with its surface scarred by tremendous ridges and canyons. In this way, Saturn's realm proved as rich and complex as Jupiter's, transforming the outer solar system from a region of abstract dots in the astronomical charts into a realm of tangible, specific, endlessly fascinating worlds. And so, with its primary mission objectives accomplished, Voyager 1 faced a choice point, a moment of profound consequence. NASA engineers, recognizing the spacecraft's continued functionality and the remaining fuel in its thrusters, proposed an extended mission. Rather than following a trajectory that would take the spacecraft eventually back toward Earth or out into a simple, solitary course, Voyager 1 would be directed toward a path that would carry it out of the plane of the solar system entirely, beginning its ascent into three-dimensional space above the orbital plane where the planets reside. This decision meant Voyager 1 would not encounter Uranus or Neptune, a deliberate choice that disappointed many astronomers, but one that served a greater purpose. The spacecraft needed to gain maximum velocity, to push beyond the grasp of the Sun's gravity as quickly as possible, to escape not merely the solar system, but to venture into the realm of the stars themselves. From this trajectory adjustment forward, Voyager 1 became something new, no longer merely a planetary explorer, but a herald of humanity meant to drift eternally through interstellar space, carrying its message into a future beyond all human reckoning. The years following the Saturn encounter were years of solitude and silence for the spacecraft, traveling through the outer regions of the Sun's gravitational domain, where the solar wind thins and space grows ever colder. Voyager 1's cameras ceased their systematic observations, powered down to conserve electrical energy. The radioisotope thermoelectric generators, devices that convert the heat from decaying plutonium-238 into electrical power, became the spacecraft's sole energy source, a diminishing resource that would slowly, inexorably fade across the decades. Yet the instruments that remained active continued their patient measurement of the solar environment. Cosmic ray detectors counted the energetic particles arriving from distant supernovae. Magnetometer sensors mapped the invisible lines of magnetic force emanating from the Sun. Plasma wave instruments recorded the subtle vibrations in the electrically charged gas that fills the solar system. In this way, though diminished in capability, Voyager 1 continued to perform science, sending data streams back toward Earth across distances that grew with each passing day. Distances that transformed the spacecraft into the most remote object ever built by human hands. The outer reaches of the solar system, the region that Voyager 1 entered during the 1990s and 2000s, form a boundary that astronomers call the Heliopause. This invisible frontier represents the place where the solar wind, that constant stream of charged particles flowing outward from the Sun, finally surrenders its dominance and mingles with the interstellar medium, the general plasma and particle environment that fills the space between stars. The Heliopause is not a sharp line, but a vast region of transition and turbulence, where two fundamentally different environments interact and compete. For decades, scientists tracked Voyager 1's approach to this boundary, watching the instruments register changes in the composition of the environment around the spacecraft. The density of particles increased. The magnetic field characteristics altered. The cosmic ray flux, the number of high-energy particles from distant sources, began to rise, indicating that the spacecraft was venturing beyond the Sun's protective bubble, beyond the shielded region that has enveloped human civilization since the birth of our species. In August of 2012, data received from Voyager 1 indicated that the spacecraft had crossed this threshold. After traveling for 34 years and covering a distance of 18 billion kilometers, Voyager 1 had finally escaped the Sun's domain and entered genuine interstellar space. The confirmation came not from dramatic change or sudden revelation, but from the subtle accumulation of evidence, the simultaneous detection of changes in multiple instruments, all pointing to the same profound conclusion. Humanity now possessed an emissary in the realm between stars, a traveler that would continue its journey for geological ages to come. The crossing of the Heliopause represented a threshold as significant as any moment in the history of human exploration. When sailors crossed the horizon beyond the sight of land, they entered a realm their ancestors had deemed impossibly distant. When explorers pushed beyond the Arctic Circle or ventured into the deepest canyons of the ocean, they entered territories that seemed to exist beyond the boundaries of the known world. In crossing the Heliopause, Voyager 1 became the first human creation to escape not merely the Earth or even our planetary system, but the immediate sphere of influence of our Sun itself. It had entered a realm that would forever distinguish it from all other objects created by human hands. To comprehend the journey of Voyager 1, one must venture into the realm of vast numbers, those enormous quantities that transform abstract mathematics into tangible cosmic reality. The spacecraft, traveling continuously at approximately 17 kilometers per second relative to the Sun, covers roughly 1.02 billion kilometers in a single year. To place this in perspective, light itself requires 8 minutes to travel from the Sun to Earth, a distance of 150 million kilometers. Voyager 1 covers this distance in just 2 weeks, yet even at this extraordinary velocity, space remains incomprehensibly vast. In the 47 years that have elapsed since Voyager 1's launch in 1977 through 2024, the spacecraft has traveled more than 24 billion kilometers. To visualize this distance, consider that it represents a voyage of roughly 160 times the distance between Earth and the Sun. If one were to drive an automobile at 100 kilometers per hour continuously, day and night without pause, it would require nearly 28 million years to cover the distance Voyager 1 has traversed. Yet the spacecraft has accomplished this in less than 5 decades, a velocity that exceeds the fastest land vehicle ever built by a factor of thousands. The distance between Earth and Voyager 1 in 2024 stands at approximately 24.2 billion kilometers, a separation that light itself takes more than 22 hours to traverse. When mission control at NASA's Jet Propulsion Laboratory sends a signal to Voyager 1, that signal travels at the speed of light, yet requires more than 20 hours to reach the spacecraft. The response, traveling back at the same ultimate speed of light, requires an equal duration. Thus, any exchange of information between Earth and Voyager 1 requires more than 40 hours to complete, a communication delay that means any command to the spacecraft must be sent with profound forethought, anticipating situations that may have changed by the time the command arrives. Gently across these years of travel, Voyager 1 has been drifting away from the Sun at an accelerating rate relative to the surrounding stars. The spacecraft's velocity relative to the Sun is fixed at 17 kilometers per second, but the stars themselves move through space, each following its own trajectory through the galaxy. This means that Voyager 1, moving at a different angle than most nearby stars, gradually increases its distance from our solar system at an effective rate that incorporates both motions. On average, Voyager 1 recedes from Earth at approximately 3.6 astronomical units per year, where 1 astronomical unit equals the distance between Earth and the Sun. Affixed to Voyager 1's external surface, protected within its golden envelope, the golden record contains within it the vast ambitions and the profound vulnerability of humanity. This phonograph record, measuring 30.5 centimeters in diameter, was constructed from phonograph-quality copper and plated with a layer of pure gold, creating an object that might preserve its contents for billions of years. The record rotates at 16 2/3 revolutions per minute, the proper speed at which any sufficiently advanced civilization might deduce to play it. The sounds and images encoded on the golden record represent a carefully curated selection of human culture and natural sounds. The greetings, recorded in languages spoken by 55 different human populations, begin with simple phrases in Akkadian, one of the earliest recorded languages, and progress through modern tongues: English, Spanish, German, French, Chinese, and many others. A child's voice greets any potential listener with words of universal significance. A woman offers a greeting in Earth's most widely spoken languages. In this way, the record becomes a voice for all of humanity, speaking across the void to listeners who might exist in a future tens of thousands of years hence, in a galaxy perhaps transformed beyond current recognition. Among the musical selections encoded on the golden record are compositions by Bach and Beethoven, acknowledged as among humanity's greatest artistic achievements. Bach's The Art of Fugue appears, representing the mathematical complexity and spiritual depth possible within musical structure. Beethoven's Symphony No. 5 captures a different aesthetic tradition, one emphasizing dramatic emotion and human struggle. These are joined by works from other traditions: a Mozart concerto, a Beethoven string quartet, a Georgian hymn, and compositions from the musical traditions of Bali, India, Peru, and other cultures. In this way, the record samples the world's musical heritage, offering future listeners evidence of humanity's capacity for beauty and meaning-making. The natural sounds on the golden record include the trumpeting of wild animals, the rush of wind and thunder, and the songs of birds and whales. There are the sounds of human activity, the roar of a train, the rumble of machinery, the whisper of human footsteps, capturing the acoustic landscape of human civilization. A mother's kiss and a child's laughter are preserved in permanent form, intimate human moments translated into grooves in gold and metal, waiting for someone, somewhere, someday to hear them. In addition to sound, the record contains photographs and diagrams encoded as electron beam pulses, images that could theoretically be converted back to visual form by any sufficiently advanced civilization. These include mathematical and physical diagrams illustrating human scientific understanding, photographs of human life and Earth's natural wonders, and diagrams of human anatomy. In creating this record, the team led by Carl Sagan made a profound statement about what humanity wished to communicate about itself, not primarily our achievements in war or domination, but our capacity for beauty, understanding, and connection. As Voyager 1 ventured beyond the familiar realm of the solar system, the nature of its existence transformed. No longer did the spacecraft pass by planets and moons. No longer did the perspectives from its cameras reveal new worlds previously unknown. Instead, it entered a realm of profound constancy, traveling through a darkness broken only by the distant light of stars, surrounded by a cosmic silence that has existed since before solar systems formed. The instruments aboard Voyager 1, powered by the gradual decay of its plutonium-238 thermal generators, continued their patient measurements, but with decreasing capability. Bit by bit, component by component, engineers at the Jet Propulsion Laboratory decided which systems could be powered down and which must remain active. The cameras that had sent back billions of bits of image data were among the first to be deactivated. The instruments used for planetary observation became irrelevant in the silent void of interstellar space. Yet the more fundamental science instruments remained, those sensors that measured the properties of the space through which the spacecraft drifted, the particles and fields and radiation that filled this realm. In this way, Voyager 1 settled into a mode of operation that would continue for decades more, sending streams of data back toward Earth across the incomprehensible gulf of space. These data streams come at a rate of roughly 160 bits per second, a transmission rate comparable to the slowest computer modems of the 1980s, yet representing an almost miraculous achievement, maintaining communication with an object so distant that radio waves require more than 20 hours to deliver messages. The engineers and scientists who maintain the Voyager 1 mission at NASA must navigate peculiar challenges in their work. The spacecraft's computer systems, based on technology from the 1970s, contain components no longer manufactured anywhere on Earth. Yet they continue to function, these ancient circuits and processors, year after year, transmitting data through receivers no more powerful than those found in satellite dishes. The feat of maintaining this communication represents a triumph not of raw power or contemporary technology, but of precision, persistence, and profound human ingenuity. The power supply aboard Voyager 1 diminishes with each passing year, a gradual decline as the radioactive plutonium fuel decays. In 2024, the spacecraft's power output has declined to approximately 4.5 watts, a quantity of electrical energy equivalent to that used by a small nightlight. Engineers have long since calculated that by the year 2030, insufficient power will remain to operate even the most essential instruments. By that date, the data streams that have continued without interruption for nearly 50 years will finally cease. The spacecraft will continue its drift through the cosmos, still carrying its precious message on the golden record, but no longer speaking, no longer sending signals home to the world that created it. To contemplate Voyager 1's future is to venture into a realm of temporal scales that challenge human imagination and understanding. The spacecraft will continue its trajectory for epochs of time that exceed the entire recorded history of human civilization, continuing to drift silently through the interstellar medium, regardless of whether it transmits data or not. In this way, it becomes something more than an instrument or a probe. It becomes a wanderer, a perpetual traveler through the cosmos. The stars nearest to the Sun, those systems from which one might theoretically expect visitors in a science fiction scenario, all lie at distances measured in light years. Proxima Centauri, the nearest star system to our own, orbits at a distance of approximately 4.2 light years, a gulf of approximately 40 trillion kilometers. Voyager 1, at its current velocity of 17 kilometers per second, would require roughly 73,000 years to cover this distance. Yet even arriving at Proxima Centauri would not bring Voyager 1 particularly close to a habitable planet, should such exist there. The spacecraft would pass through the system at a distance measured in billions of kilometers, perhaps close enough for advanced astronomers to detect it, but unlikely to intersect with any world where life might exist. More likely, Voyager 1 will continue its silent voyage through regions of space entirely devoid of stars or planets, traveling through the vast gulfs that separate stellar systems. The Oort cloud, that theoretical spherical shell of comets and icy bodies that surrounds the solar system at distances of between 2,000 and 100,000 astronomical units from the Sun, may potentially be encountered by Voyager 1 in the very distant future. To enter this region fully and travel beyond, it would require many tens of thousands of years, a span of time equal to that which has elapsed since humans first began creating cave paintings on Earth. In approximately 40,000 years, Voyager 1 is calculated to pass within 1.6 light-years of the star Gliese 445, an event so distant in the future that it exists in a realm beyond normal human comprehension. The time between now and that encounter is longer than the entire span of human history. In 40,000 years, human civilization will have changed in ways impossible to predict, yet Voyager 1 will still be traveling, still carrying the golden record with its messages from a civilization that existed in the distant past. In the end, though end remains perhaps an inappropriate word for a journey that may continue for billions of years, Voyager 1 will eventually reach a state of thermal equilibrium with the interstellar medium, its temperature matching the average temperature of the region through which it drifts. Its trajectory, influenced infinitesimally by the gravity of countless distant stars, will eventually be altered beyond recognition. Yet the spacecraft will continue its travel, continuing its existence as a physical object moving through the cosmos long after every star currently visible to human eyes has expired, long after the very atoms that compose the spacecraft have been recycled through different forms of matter. As we contemplate Voyager 1's journey, we must also consider what it means to venture into a realm of near-absolute silence, a realm where the only sounds that might ever be perceived are those that the spacecraft itself generates through its occasional instrument adjustments or radio transmissions. This silence is not the absence of something expected, but rather the fundamental reality of the vast majority of space. The distances between stars are so immense that the sound of any single event, the explosion of a nearby star, the collision of celestial objects, would arrive as barely a whisper across the cosmic gulf, if it arrived at all. In sending Voyager 1 into this silence, humanity made an implicit statement about the value of persistence and exploration, even in the face of apparent emptiness. The spacecraft represents a faith that knowledge and understanding matter, that sending a messenger into the dark carries significance regardless of whether that messenger will ever encounter another consciousness that can understand its message. For this reason, Voyager 1 becomes a kind of monument to human curiosity and ambition, not a monument built of stone or metal upon a world's surface, but a monument that travels, that persists, that witnesses. The relationship between Earth and Voyager 1 has transformed across the decades. In its early years, the spacecraft was a tool, an extension of human agency, receiving commands and sending back observations. As the years progressed and the spacecraft moved ever farther into regions of space about which scientists possessed less knowledge, the relationship became more mutual. Scientists on Earth learned from what Voyager 1 reported, yet Voyager 1 itself became an object of fascination and concern, a presence that represented something larger than its physical dimensions or technical specifications. The knowledge that a human creation was traveling into the distant cosmos, carrying humanity's cultural and scientific message, resonated across human consciousness in ways that transcended the merely scientific. Writers, artists, and philosophers found in Voyager 1 a symbol of human transcendence and vulnerability simultaneously. The spacecraft represents our reaching outward, our hope that our works might persist beyond our own existence, our desire to communicate across the vast gulfs that separate us from potential others. At the same time, it emphasizes human fragility. The spacecraft is small, its power source is finite, its existence is tenuous compared to the vast time scales of cosmic history. As Voyager 1 drifts onward through the present moment in 2024, its power levels continue their inexorable decline. The plutonium-238 fuel that generates the spacecraft's electrical energy diminishes at a rate of roughly 2.2 watts per decade, a decline that was carefully calculated and planned for even in the original mission design. Engineers have already implemented strategies to manage this fade, powering down non-essential instruments and reducing the frequency of transmissions in anticipation of the day when insufficient power remains to maintain even basic operations. The future of Voyager 1's data transmission appears likely to conclude sometime around the year 2030 to 2035, when power levels drop below the threshold necessary to operate the remaining functioning instruments. At that point, the spacecraft will effectively become silent, no longer sending signals back to Earth, no longer transmitting the data that has connected it to human consciousness for nearly 5 decades. From that moment forward, Voyager 1 will drift through space without contact with its creators, continuing its eternal voyage in complete isolation from any awareness that it once carried a message meant for distant, unknown receivers. Yet this silence, when it arrives, should not be understood as a tragedy or a failure, but rather as a natural conclusion to a phase of existence. The spacecraft will continue to exist as a physical object, will continue to move, will continue to carry the golden record and all of humanity's hopes and messages encoded within it. It will simply exist without transmitting, a wanderer without a radio, a messenger in perpetual transit. In this way, Voyager 1 achieves a kind of immortality, not the immortality of eternal communication, but the immortality of persistent existence, of continuing journey even when observation from the original world has become impossible. The golden record itself, protected by its golden casing, might potentially survive for billions of years. The grooves that encode the music and images have been designed with longevity in mind, created in a manner that might enable any sufficiently advanced civilization to decode them even after vast epochs of time. The materials of the record itself, copper, gold, and specially treated film, are resistant to the corrosive processes that would destroy many materials across cosmic time scales. In this way, the message carried by Voyager 1 might achieve a permanence that outlasts not merely the spacecraft that carries it, but potentially the sun itself. In considering Voyager 1's slow fade into technological silence, we are reminded of the transient nature of human creations and the vast permanence of physical reality. The spacecraft represents human ingenuity, human hope, and human ambition at a particular moment in history. The 1970s, when space exploration had captured global imagination, and when humanity still believed in grand missions of exploration and discovery. Yet the cosmos existed long before the spacecraft was built, and will exist long after all traces of human civilization have vanished from the universe. And so we arrive at a conclusion that is not truly a conclusion, but rather a recognition that some journeys never end. Some voyages continue beyond the comprehension of those who sent them forth. Voyager 1 drifts onward as it has drifted for nearly 5 decades, as it will continue to drift for epochs of time beyond human reckoning. It carries within it the hope of a species that believed that curiosity and exploration matter, that understanding the cosmos represents something worth pursuing, that sending a message into the dark serves a purpose even if no one ever receives it. The spacecraft's journey reminds us that distance is not an absolute barrier to connection, that information can traverse the vastest gulfs, that the desire to understand and to communicate transcends the limitations of physics and time. Voyager 1 represents the furthest extent of human reach, the most distant object that bears the imprint of human hands and human thought, drifting perpetually beyond the grasp of the civilization that created it. In the darkness of space, far from the sun that birthed both Earth and Voyager 1, the spacecraft continues its motion, its trajectory curved only infinitesimally by the gravity of distant stars, its essence unchanged despite the decades of travel and isolation. The golden record spins slowly within its protective envelope, its groove standing ready to play humanity's message if ever the right hands and the right ears should find it. The instruments that still function record the properties of the interstellar medium, sending their signals back across the vast gulf, toward a planet its creators no longer inhabit in the form they did when the spacecraft launched. We might imagine Voyager 1 as a kind of time capsule not merely in space, but in consciousness, a continuation of human curiosity extending far beyond any single individual life, or even the collective lifespan of human civilization. It becomes, in this sense, less an object we have sent out and more an extension of ourselves into the far future, a proxy consciousness witnessing the cosmos long after the beings that created it have transformed into something unrecognizable. The silence surrounding Voyager 1 is not empty but full of meaning. The darkness through which it drifts is not barren but fertile with possibility. The distance that separates it from Earth is not merely a gulf of kilometers, but a bridge of understanding, a connection that demonstrates the fundamental human need to explore, to reach outward, to leave behind some trace of our existence even in the most unlikely places. And gently, across the years and decades yet to come, the spacecraft will continue its eternal voyage, a silent messenger carrying humanity's words and music toward destinations it will reach only after unimaginable spans of time. It drifts now through the darkness and will continue to drift long after this moment has faded into history, a small point of light-reflected metal continuing its journey into regions of space where no human eye will ever see it, yet knowing it travels there, knowing it carries our message, knowing it persists. The cosmos is vast and largely empty, yet now it contains within it this small artifact of human achievement, this traveling library of human culture and hope, moving steadily forward through the eternal night, a wanderer that will never rest, a messenger whose delivery date extends billions of years into the future, if ever a delivery arrives at all. Let yourself drift now with this thought, with the image of the spacecraft moving silently through the darkness, continuing its journey as you settle deeper into the quiet and the peace of this moment, knowing that somewhere far beyond the farthest stars, Voyager 1 continues its eternal drift. Word count: 6,487 words.